Hello and welcome back to the Cosmic Cat, and in this video we are going to learn what is golang concurrency and how can we achieve golang concurrency. So there's the concept of go routine there, so we'll see that in action. But before getting deep dive into code, let's discuss this so that we can get a clear picture of what we are going to learn. So concurrency is the ability of a program to manage multiple tasks simultaneously, right? Imagine you are at a very busy pizza shop and where multiple activities are happening at once. Let's say dough is getting prepared, toppings are getting prepared, and then cheese are getting prepared, and then finally combining all those together, right? The pizza is finally being prepared, right? And you can see there, although each task seems independent, right, they are cooking them independently, but finally they are interconnected. And how can we say that? The shop must coordinate all those items at once so that the pizza is finally ready, right? So this coordination is called concurrency in real life, right? In programming, concurrency works similar way, managing multiple tasks or operations without blocking the progress of others, right? Now first thing we need to understand is difference between concurrency and parallelism. So most of the people thought concurrency and parallelism are same, but no, we have little difference over there. So what does concurrency means even though task appears to progress at the same time, right? But a single safe switch between preparing dough and adding toppings, right? You can switch between multiple tasks to handle so that it seems you are handling those parallelly. That is called concurrency, right? But then when it comes to parallelism, tasks run at the same time, but on different workers. Means you won't be involving in the other task, you will be involving only in a single task, and then other task will get handled by someone else. That is called parallelism. All right. So in this video, we are going to create a pizza. All right, and we'll be having all those ingredients in our hand. Based on that, we are going to create a pizza, and we will include all those golang concurrency topics or concepts in this video so that you can understand it very easily. And to be honest, golang concurrency is very easy to write, very easy to understand. And for that, let's come here, and this time we are going to create a new pizza making process. So very first thing what I'll say here is, okay, we need a type of ingredients so that it will hold all those ingredients value or item. That of course it is going to be dough, it is going to be cheese, or whatever you want. So I'll say it as ingredients, and then not ingredients but ingredient, and then it's going to be a struct, because we can have certain data over there in this ingredient. So here I can say, okay, this is ingredient, and then I need a name of the ingredient. So I'll say string, and then I will say preparation time. Of course this ingredient will take some time to prepare, right? So that I can show you exactly how it is working. Okay, so I'll say preparation time, I'll say preparation time, and then it is going to be of type time dot duration. All right, so now it is expecting a time, and then we have name of the ingredient. We are good with this ingredient. Now we need a function to prepare this ingredient. So what I can say is just register one function on this ingredient, and I will say I, and then it is going to be of type struct, ingredient struct, and then we can say prepare, right? We have this function ready, prepare on this ingredient. So let's very first create this ingredients. I will say ingredients, not ingredient, it should be ingredients. Let me just make this variable name. Okay, and then how can we make this? We know that this is how we can make array of ingredients, because we have lot of ingredients over there, that is dough, cheese, or toppings, anything, right? So here what I'm going to say is, okay, ingredients is there, and then it's going to be, let's say, of type not string but ingredients. Cool. So now we should be able to assign multiple ingredients here in the ingredients variable, right? So here I will say, okay, name is going to be string, not string but this time dough, let's say, and then time it is going to take, preparation time is going to be, let's say, one, dough is going to prepare in 3 seconds. Let's say, for example, you can put any values you want. Just try this. So I'll say time dot second. So it will take 3 seconds to cook this, and then I will add couple of more ingredients. So I'll say cheese this time, and then cheese is going to take, let's say, 1 second, and dough already is there. So this time I'll say just use toppings. Alright, so now topping is going to take 2 seconds, for example. So now we have ingredients ready over there, right? We have this, and then finally we need to call this prepare method on each of the ingredients, because this ingredient should be prepared first, and then only the pizza should start baking, or then only we should start making pizza, right? So for that, what I will say is, okay, this is completely fine. We have created this ingredient. So I will say, okay, just print something onto console so that we can say, okay, that's fine. So I'll say println, and this time I'm going to say order has been, let's say order has been received and sent for preparation. Let's say you have received one order, and then you are preparing these ingredients, and then this ingredient will now go for preparation, right? So that you can finally create or bake a pizza. So in this case, we are good here. So we need to prepare all of these ingredients, right? And for that, we need to call prepare method on this ingredient. So how can we do that? We are going to use for loop. We know that we can loop over this array or slices, and then we can do the action. So I'll say, okay, the actual ingredients, it should be ingredient, and then it should be coming from where? It should be coming inside a loop. So I'll say loop over ingredients, and then just call prepare function. So I'll say ingredient dot prepare, right? Now we are good till here, but then we have one issue over here. When you are sending this data, right, this ingredient to prepare, it should not prepare one by one, right? Or you are not going to wait for cheese to be prepared first, or toppings to be prepared first, and then so on. Instead, you want all this to prepare parallelly, correct? So for that, we need to launch this preparation parallelly. And how can we do that? That's the concept of golang go routines. All right, that's a very powerful feature in golang. Basically, we are going to use go over here. Go says if you want this functionality to be executed on a separate go routines, right? If you want this functionality to be executed on separate go routines, you need to just put go in front of the function which you are executing, right? So as soon as you will say this specific functionality will execute on a separate go routines. That means this functionality is no more on the main go routines. It's completely handling parallelly, going to handle parallelly, right? Because we need all these three to be prepared parallelly. So we are using go, and then ingredient name dot prepare, then it is going to be handled parallelly. But then once this is prepared, just assume one scenario. Once this, since it is going to handle or executed on a different, prepared on a different go routines, but then once that is prepared, how we will get those data back? How we will get the information from that go routine, because it is running independently, right? So for that, we need something so that we can send our voice from there to this specific main go routine, right? We need to say from there, okay, we are done executing this, we are done preparing this ingredient, all right? And then we should be able to communicate that. For that, we need a communication channel, right? So Go says, okay, you can create a communication channel between multiple Go routines. And how can you do that? So we are going to say, okay, var, and then I will say communication channel, and then I'm going to say, okay, and make a communication channel. I will say, we know that we have a make function in Golang. So I'll use this make function to create a communication channel. So this time I'm going to say, okay, I will just say the name of the specific ingredient which is prepared. So that means the string data will be transmitted from there to this specific Go routine, main Go routine. So I'll say, okay, create a channel of string. All right, we are now done with creating a channel. And then we need to use this channel so that we can say, okay, we are done with preparing. But then from where we need to say this? We should have the access of this communication channel somewhere, right? At a centralized place, right? So this is the centralized place, but we need to pass this to each of those prepare method, so that each of this go routine, let's say this is one of the go routine, I will say go routine 1, and I will say here go routine 2, go routine 2, right? And then here I will say go routine 3, go routine 3. Now this independent go routine will have access to a single communication channel, correct? And then using communication channel, they will be sending us back the message, okay, I am done preparing this ingredient, now you can start making pizza, correct? So how can we do that? So for that, what I'm going to say is, okay, just pass this communication channel in the prepare method, so that we can say if we are done with preparation, right? So I'm going to say, okay, I need a channel over here, so I'll say channel, and then it is going to be of string type, channel, right? This is variable name and this is data type of a string, right? And we are good. Now we should be able to pass this communication channel here. That's completely fine, right? That is it. And then here what we need to do, we need to start preparing those ingredient, right? So I'll say println, and I will say, okay, now this time I'm going to use this printf to format the string because I need that. So I'll say, okay, is started preparing, all right? And then I will just pass this actual value of ingredient dot name, so that we can exactly see this specific ingredient started preparing. And then I'll just copy paste it here, and here I will say prepared. So I'll say prepared, okay? And then in between we can, let's say, delay this execution, or we can just sleep the go routine for a certain duration, so that we can identify, okay, this is going to take this much of time. After this much of time only this specific ingredient is going to be prepared. So I will say time dot sleep. We have sleep functionality over there, which will sleep that specific go routine for a certain duration of time. So here I have that duration, preparation time, which will be acting here as a duration, right? So that it will sleep this go routine for the specific duration, right? Simple, very simple. So now once we are done with that, we need to send this message back to the main go routine. And how we can send that? We know that we need to use channel for that. So we are going to say, okay, use this channel, and then this is the symbol you need to use, okay? And then the data which you want to send. That means I will say I don't name. Once this is prepared, this name will get passed to this channel. That means we are pointing to the channel, okay, just pass this name to your channel, and this, wherever this channel is defined, it will get this message, right? Very easy. So now we are done with this prepare, and finally one more thing here we need to say, okay, once this is being prepared, until all this specific item is prepared, we need to wait for that, right? But how can we wait? Because this all three will run parallelly, correct? Not parallelly, but concurrently. So how can we wait for all this to be prepared and then we should start making pizza? For that, golang says, okay, you can use one more thing over here, and this time this is going to be wait group. That is exactly the wait group is. So it is basically present inside sync.wait group package, not sync.wait group, sync package. And then using this wait group, we can say, okay, until the execution of the specific functionality completed, don't close your thread or don't close your go routines. All right, once that is completed, then only close this main go routines. Okay, you need to wait for all the go routines to be completed, then close the main go routines. Otherwise, what will happen? All the go routines will run parallelly or concurrently, but then main go routines will unaware of that, and then it will close itself. And once the main go routine closes, everything will get closed ultimately. All right. So to avoid those situations, we need to say this wait group to wait until all those go routines has been, completed. And how can we do that? So here we are going to say, okay, that's completely fine, but you need to wait as well. So I will say, okay, just execute this function, and this is kind of immediately invoked function, you can say. And here I will say, just type wg.wait. That means it will wait for all those go routines to be completed, then only it will pass to the next execution. Fine. That means it will just tell this main function to hold on until all those go routines has been completely executed. Cool. It's very easy concept, right? And then one more thing we need to say, okay, once all those go routines are completed, we need to close the channel as well. So because we don't need that channel anymore, right? So for that, for closing a channel, we have close function on golang, and there we just need to pass the channel. So this time we have this communication channel. I will just copy it from here and paste it here, right? Once we are done with all those go routines, of course the wait should be over, and then we should be able to close this channel. Correct? We are done with this, and then finally, after preparation, not here, it should happen after we send those for preparation. And let me just expand this so that you can able to see it clearly. And then here I'm going to say, okay, that's fine. Next, I'm going to loop over this channel. Now whenever those message is being passed from here, right? So you should be able to pass this message to this channel. Okay, channel will receive this, but then you should be able to read those messages as well, right? Then only you can say, okay, I read this message. You send the message. You send one message. Let's say dough is prepared. I should be reading those messages as well, so that I can say, okay, the dough is finally prepared. So for that, I am just going to iterate over the channel, and then if any message is coming, it will just pick over that message and read it. How can we do that? So for that, we can say, okay, and this time we know that from the prepare function we are sending only the name of the ingredient. So we can say name, and then it is going to be range over what? This time it is going to range over channel, because it's communication channel, because the message which we are listening for present on this channel will be present on this channel, will be coming through this channel, right? That's why we are putting for loop over here. So it will just wait for that channel to receive any message. And then what I am going to do here is, as soon as the message is received, I am going to maintain a variable here, ingredients name. And what it will do, it will collect all those names at once. Not at once, but whenever that specific item is prepared, right? So I'll say I'll create a slice of a string which will store the name only, right? And I will say ingredients name dot append. So it will use this ingredients name. Of course we are using append function here to append a new name, and then we'll say name. That means whenever new ingredients is prepared, we'll get those messages here in the communication channel, and then we'll assign that name into this ingredients name, right? And then your code of execution will be here so far until all those go routines has completed successfully, right? Now once that is successful, I will say, okay, let's match this, the ingredients which I have passed, I have sent for preparing, and with the ingredients which I have received, right? It should be the same. If I sent dough, cheese and toppings to be prepared, then all those I should be getting back, so that I can prepare the final pizza. So I'll say ingredients, and then if both lengths are same, I can say fmt.println, and then I can say, okay, pizza is ready now, and you can collect the pizza, you can collect your order, you can collect the order. Cool. That's completely fine. But then one more thing here we are done with, we have created this ingredient over here, right? We have registered a prepare functionality. Of course that ingredient has to be prepared, and after certain duration it will be prepared, and then we are sending that ingredient name back to the channel, from where it is being passed, right? So that we can listen for all those go routines on a single place, right? So here we are listening for that, and then one by one, if we are getting ingredients ready, that ingredient is actually being prepared, then we are assigning that ingredient's name to this specific array. And finally, we are checking if we have the same length. If all those ingredients is prepared, that means we'll have all those names here, right? In that case, ingredients is, that means pizza is now ready, and then we can collect the pizza. Or else we can say some items are missing, right? So here we can say some items are missing from, some items are missing to prepare pizza. Cool. So far we are good, right? It's easy. Now here what we are saying is, okay, until this all message is finally came, right? Finally we have received all those messages from all of those go routines. We don't need to close this main go routine. Otherwise, if we'll close, ultimately all those go routine will get closed. So for that, we need to say explicitly, okay, wait group, you have to wait until all those go routines has been completed, right? But then question is, how will this wait group will know we have to wait for 10 go routines, or we have to wait for 3 go routines, right? How this wait group will know? So for that, we need to specifically explicitly tell this to go routines, okay, just add this in your count. What to add? So here, when we are sending this for preparation, there itself we will say, okay, since we are launching a go routine here, right? You can see go in front of this function. So when we are launching this go routine here, we can say, okay, wait group, I am launching one go routines, and I will just add one go routine in your configuration. I'm just saying you every time I'm adding one more go routine until this item iteration are over. That means in this case we have 3 items. That means I have added 3 go routines here. Correct? Now this wait group will have 3 go routines there in their list, right? And then it will wait for all those 3 message, or it will wait for all those 3, not message, but it will wait for all those 3 functionality go routine functions to be completely executed successfully or unsuccessfully, whatever. But then if that is completed, that functionality is executed properly, then this go routine will just remove one from their list. It will just maintain a note of all those go routines. As soon as that is executed, it will start removing that from its note, and then finally if it won't be having any note present, then it will just close this main go routine, not main go routine, but wherever you are calling this. In this case we are calling this on a main, of course, then it will terminate the main go routines, right? Not terminate, but it will pass the execution to the next line of code. And if there's no code, of course this function will get closed, the application will get closed, right? And then of course on close we should also say close this communication channel as well, because we don't need any more, right? As simple as that. So let me just save this. And one more thing here we need to do, how wait group, since we said it explicitly to the wait group, okay, we are giving you this add, you just add one go routine in your list. That means totally here, as per this for loop, totally 3 go routine will be there in your list, right? But then how will this wait group will decide, okay, that a specific functionality is executed or not? They have 3 go routine in their list, but how will they know this is executed or not, right? For that we need to pass this wait group here in this function prepare, so that from this function we should be able to tell this wait group, okay, I am done, okay, one wait group is done, or one go routine is finally executed, because this prepare function is launched as a executed as a go routine right here. Correct? So here what I need to say is, okay, pass one wait group, and this time I'm going to accept pointer of wait group. Right? Now, very first thing at the beginning of this function, wherever you are writing this kind of code, you just say defer wg dot done. Or to be more secure, or to avoid any kind of error, you can just say if wait group is not nil, you can check for wait group. If it is not nil, you can do wg dot done, and not done, but then you can say defer. What this defer will do actually, whenever the function is completely executed, then this specific line of code will get called. That means before any functionality, if you are going to put defer, right, it will wait for the specific line to be executed until all of the code present inside those functionality is executed, and this specific line will get executed at very last, right? So this is how we are going to say, okay, once this is all done, we are going to say wait group, to the wait group, we are done with 1. And similarly, if 3 is there, means we are done with 3, correct? So now just save this, and then here what, okay, here we need that wait group. So I'll say send the address of the wait group, and I will just save it. Let me just clear the console and we'll run this, and we will see if that is working fine. So for that, I'm just going to say go run main.go, and we can see here topping started preparing, dough started preparing, okay, buns, but what we are getting some error over here. And what is that error exactly? Deadlock. Okay, there is concept of deadlock as well. We'll talk that in a separate video, but let's try to overcome this scenario. So here, up to here we are good. We have created ingredients, all right, and then ingredients is fine, and then we have ranged over this ingredient, that is also fine. We have added wait group as well, that is also fine. Go ingredient prepare, and then we are closing the channel as well, that is also fine. So then finally we are iterating over communication channel, right, that is also fine. So then what can be the issue? So defer wg dot done. Okay, let's remove this, instead just put defer wg dot done, and we'll see if that works. So let me just save this, and we are good here till here. And yeah, let me just save this, and I will just clear this console and run it once more. Again it goes on a deadlock situation, and why is that so? We need to debug this and find out the exact issue. Why is it happening? All right. Okay, so we found issue over here. We are directly launching this function as a synchronization function. That means it will always wait for this till here itself, and then there won't be any code executing here. So for that we can say, okay, launch this as a go routine as well, and then this will just wait for the specific go routine to be completed, and finally this will close the channel. So let me just save this back, and then I'll test it once more. I'll just clear this console, and I will say go run main.go. Let's see if that works. Yeah, that actually works. We are getting, okay, order has been received and sent for preparation, right? Now we have sent these items to get prepared, and finally once this item has been prepared, we say that pizza is now ready and you can collect the order, because this ingredient name we are receiving over here. And if you want to be more specific, you can put fmt.println here as well, and you can say, let's say I'm going to use sprintf. So I'll say sprintf, and then here I will say %s is ready, right? And of course this is the name of the ingredient which is ready. So let's see that once more, and I will clear the console and execute this program once more, run this program once more, so that we should be able to see when that item is prepared. So we can see here cheese is ready, and then we are seeing toppings is ready, and then dough is also ready. Finally collecting all those together, we are done with creating the pizza. So this is it for this guide, this video guys, and I hope you will be able to understand this concept of golang concurrency and how this wait group, go routines, and then communication channel works, right? It's very simple, and this is how we need to create this. So if you guys are facing still issues, or if you guys are having any difficulties writing this code or anything, just let me know in the comment section. I will try to resolve that as early as possible. Meanwhile, you can put subscribe and press the bell icon button. And thank you guys. I will meet you in the next video.